what makes something flammable and one thing flammable and one thing not flammable. But you don't need to know that. What you need to know is that, if you're working with something flammable, there are certain safety precautions that you need to take. As far as storage goes, oftentimes these things are stored in a flammable storage cabinet or even a refrigerator or a freezer. If you have a spill of a flammable material, you want to get it cleaned up as quickly as possible, because the longer it's down there, the more vapors can waft into the air, and that's really what ignites. If you have a spark, whether it's a light switch or static electricity, it's the vapor that ignites and starts the fire. Corrosive chemicals. These things, they basically damage your tissue, whether it's your skin or your eyes. Even if you breathe in a corrosive vapor, it can damage your respiratory tract. Pretty easy to define. Anything with a pH less than 2 or above 12.5. They can also react violently with water. So if you have a spill of a corrosive chemical, you want to prevent it from going down the drain where there's a bunch of water. And also, they can corrode metal and generate hydrogen gas in the process, which is flammable. So again, if you have a spill and it's right next to a piece of equipment, say with a metal stand or metal legs, you want to try to prevent it from reaching that. I think that the take-home thing with corrosives is you don't want it touching yourself, and pretty much for the most part, you don't want it touching anything else around you either. So you just want to be very careful when you're working with them. Oxidizers, again, these things are very reactive, especially with organic materials such as human beings. Can sometimes react violently and burst into flames. And some obvious physical hazards associated with this: serious burns or irritations to your skin, and again, your eyes and even your respiratory tract. So you want to be careful with this stuff, obviously. All right, there are different types of health effects. Acute health effects often occur rapidly, and they're only of short duration. You can think of burns, rashes, and irritations as the primary example. Chronic health effects, they occur after a long period of exposure, and the effects are also of long duration. Cancer is the #1 example of this. You can also develop allergies if you're continuously exposed to certain things. So when we think about the risk of an exposure, we think in terms of the dose, how much have you been exposed to, as well as the duration, for how long have you been exposed to it. And you obviously want to minimize the risk of exposure. So what you do is you want to try to minimize both the dose, again, how much, and the duration, again, how long. The #1 way to do this is wear your protective clothing. If you're wearing gloves and you spill something on your gloves, you're preventing the chemical from even contacting your skin in the first place. If you're wearing goggles, you're preventing the chemical from even contacting your eyes in the first place. So that's the #1 way to do it. Also here at PC, we've designed experiments so that they use the least amount of chemical possible. And, here at PC, just as an aside, here at PC, you're not going to be working with a lot of nasty stuff. You're really not. And the thing is, though, if you take it seriously and develop a safe ethic in your mind, a safe work habits, not only the work habits, but a safe mentality in your mind, you are going to be that much more prepared for your life after PC. Whether you go into grad school or whether you go out into industry, you're going to be more hireable. Companies and institutions aren't going to want to spend hours and hours trying to train you in what they consider to be essential safety practices. So if you get it in your head now, you're going to be better off later on. All right, so I talked a lot about how chemicals can hurt you. Now, the question is, where do you find out this information? How do you find out if a chemical is hazardous and how exactly it's hazardous? The #1 primary go-to source for hazard information is what's called a material safety data sheet. Some of you may have experienced with this in the past, or sometimes they're called MSDS. But anytime chemical is made, all these manufacturers, they have to make material safety data sheets for their products so that when they sell it to you, they send you a material safety data sheet along with the product. Chemical manufacturers are also required to put hazard labeling right there on the label on the bottle. So you'll see it that way a lot of times too. Also in your lab manuals, they have notations in them explaining when you're going to be working with something that's hazardous and what the hazard is. All right, so MSDS, Material Safety Data Sheets. Again, this is the primary source for information. You can access them online, and we have hard copies in the GenBio lab, should you need to access any of that. There's actually a minimum content requirement for material safety data sheets by law. And I'm not going to go over this entire table and what is in it, but as you can see, the information on a material safety data sheet is very broad. But I will highlight a few very important areas. One is the hazardous ingredients. If you're working with a solution of something and it's got hazardous chemical X in it, you want to know, does it have 1% hazardous chemical X or does it have 99% hazardous chemical X? Because it's a very big difference. Also, health hazard data, you're going to find first aid information, first aid procedures. If you are exposed to this chemical, what first aid procedures should you practice? Do you wash your hands for 15 minutes? Do you flush your eyes? A good one is if you get it in your mouth, there's a number of things you can do. Some chemicals you don't want to induce vomiting because it'll tear up your trachea. Others, you want to drink copious amounts of water or even copious amounts of milk. So again, this is good information to know before you actually have an exposure. Also, protective measures. What sort of protective clothing should you be wearing to prevent an exposure to this chemical? So those are really three important areas for MSDS. All right, so labels, as I said, if MSDS is the primary source for information, labels are the quick and easy reference. Again, most of the time, what chemical manufacturers put on their bottles is sufficient. Sometimes the faculty will put additional hazard labeling on there, additional stickers on there, if they need to. If they put something in if they transfer a solution to a new container, they'll label it. They'll put hazards on it. I don't know. You probably can't see it from there, but this bottle right here is a generic white plastic bottle, and they put acetone in it. So what they did is they wrote the word acetone on it and stuck a flammable sticker. That's that small red dot. They stuck a flammable sticker on it. So now when you go to use this, you know what it is and you know what the hazard is as well. And that's a perfect example of the way it should be done. All right, there are other hazard labeling systems out there that cover a variety of hazards. This one, I'm sure most, if not all of you, have seen this. It's sort of the fire diamond, sometimes it's called. But it's got a health hazard rating. It's got a fire hazard rating. It's got a reactivity hazard rating. And down at the bottom in the white has a spot for specific hazards. And this rating system goes on a 0 to 4 scale. 0 being there's no hazard at all, 4 being the most hazardous. And the thing to sort of take away from this is that if there's 3s and 4s on there, you probably want to take a look at the MSDS to find out some more specific information. How do you protect yourself? What are the first aid measures to be taken if you're exposed to it? That kind of thing. Sometimes you'll see it, instead of laid out in a diamond, you'll see it laid out in bars like this. But it's the same rating system, 0 to 4. All right, I'm going to talk a little bit about personal protective equipment now. I'll start off with gloves. And these are some very common sense rules for gloves. You always want to inspect them when you put them on. Don't just assume that they're okay just because you pull them out of the box. They might have nicks in them. They might have tears in them. You want to take your time and look at it when you put it on. Don't take the gloves outside the lab. If they do have anything on them, you don't want to be introducing that hazard out into the environment. If you don't get anything on your gloves, go ahead, take them off, throw them in the trash at the end. That's fine. If you do get them contaminated with something, you get something spilled on them, you're going to want to throw those gloves in a hazardous waste receptacle. Your professor will set you up with that. They'll tell you exactly where to put them. So you want to go to your professor in that case. And lastly, again, as soon as you notice any sign of damage with the gloves, take them off, throw them away, get a new pair on. These things come in boxes of 100, so you don't need to worry about running out of gloves. And I also want to take some time right now to demonstrate the proper procedure for taking off gloves. I know some of you may have some experience with this in the past, depending on what high school you came from or what job you may have had in the past. But some of you may not, so that's the only reason I bring it up now. But what you want to do is you don't want to have the outside of the glove come in contact with your skin. So what you're going to want to do is, very simply, for the first glove, just pick it up by the palm and pull it off like that. You crumple it up into a ball in your second hand, and then you're going to want to slide your finger into the glove of the second hand so that it's not touching the outside of the glove, it's touching the inside. And then pull it off, and that way you haven't touched the outside of the glove at all with your skin. Okay, a little bit about eye protection. When you are working in the teaching labs with any sort of chemicals, goggles are to be worn at all times. That's the policy that we have here at PC. If you're working with a research professor, maybe as a work-study student in their research lab, it's their responsibility, it's the professor's responsibility to assess the hazards of what's in their research lab and then figure out what form of eye protection is most appropriate, and they'll let you know. They'll tell you what form of eye protection you need to wear in their lab. Okay, this graphic is sort of self-explanatory in some ways, but as you can see, they put different forms of eye protection on this mannequin. From the left, you have the least protective, just generic safety glasses, and on the right, you have the most protective safety goggles. And then, I don't know what they did. They probably shot this mannequin in the face with a huge red paintball, but when they take the eye protection off at the end, you can see the after effects. And well, again, it's pretty self-explanatory. That's why we require goggles to be worn. Offers you the most protection. All right, you may want to keep the box or the plastic wrapper that your goggles came in for storage. Oftentimes we set these goggles, face down on the work surface where the lens can be nicked and scratched. And if you take a look at this picture here, another hazard of laying your goggles around like that is it looks like somebody was weighing out some of this white powder in a scale, and some of it spilled on the lab bench, which is right next to these safety goggles. Now, we don't know this, but some of that might have spilled inside the goggles. So the next time somebody goes to put their goggles on, they're introducing that hazard straight into their eyes. So you want to be careful of where you store your goggles and how you treat them. All right, there are a few different kinds of wastes that you're going to be generating in your lab. The most common form of waste is biohazard waste. This is an example of a biohazard waste box. Things like specimens will go in there, all your slides will go in there, and a number of other things. Your professors will tell you exactly what needs to go in there. You may also generate chemical hazardous waste, which is a little bit different, and I'll talk about that in a couple slides. There's also sharps containers. These containers are small, hard plastic red containers where you're going to put things like needles from your syringes and things like that. The last option for waste is the trash and the drain in the sink. You want to assume, for the most part, that these are off limits. If there's anything that's okay to go down the drain or into the trash, your professor will tell you, but you don't want to assume that it's okay to do that. All right, another note about biohazard waste. No liquids are allowed to be put in the biohazard waste. If you're working with a specimen that's mixed in with the fluid, drain the liquid out first and then throw the specimen in there. Oftentimes that fluid will be drained into a hazardous waste, a chemical hazardous waste container. But again, you don't want to assume that it's okay for the drain. Your professors are the only people that can tell you when that's okay. Chemical hazardous waste, these things are easily identified.